So this video now will demonstrate step 3 of the 6-step programming process for developing the operating system's simulator. Again, it is critical that you use a structured process for developing this program. If you really just start trying to hack some code together, this will take you a lot more years than this semester offers you. So let's go ahead and take a look at our code here. We're back to what we had with step 1 and 2. We've got an include in here for this kind of stuff right now. Don't sweat these. These are things that I'm putting in to make things work. But I'm looking more at the structure of development right now. Okay, so for our initialized program, initialized variables, not much to that. For showing title now, what we're going to have to do is we're going to have to print F for that. So as we mentioned previously, this is the opportunity to show the user what command line arguments are necessary for this program. However, we do not want to put in all this stuff right here. It just detracts from running the program, and we know that we're going to be using that a little bit later on as well. So we'll go ahead and we'll call for a function called show program format, and then what we'll do is we'll go ahead and we'll stick in our show program format here. We're using a slightly different process for doing the structure on your functions. And I'm showing this, most of the functions are going to have a different process for this, but I'm showing this because you have options. It doesn't matter what your structure is, it matters that you have a structure. So this right here is show program format. It displays the command line argument requirements. There's not much else it does, although it is a device output right here that in fact puts the instructions on the monitor. Okay, so we've set that up, and for step 3, we just stub it out, and life is good. We're coming back up here to where we put in the show program format, unsetting the flag and setting flags. That's not too much. Initializing the file name to empty is an assignment. We're going to loop across the arguments here, starting at 1, and that really is just a loop and a count right there with a flag. And so our next step right here is to find the lengths to verify the file name here. Again, as I mentioned before, we will find the length of the file name itself that was given, but we'll also find the substring length just to make sure that that's going to work for us to get that .cnf at the end of it. So for this right here, we're going to use get string length and find substring. Okay, we're going to check for DC. That's going to require a compare string. Again, we're just setting flags here. Check DM is going to be a compare string, setting flags. Checking RS is going to be a compare string, setting flags. And then last but not least, we'll pull that file name into the variable. We'll have to have checked to see if it ended in the .cnf. We're going to use that substring quantity in the file length that we found a little earlier and make sure that we've got a file that at least ends in .cnf, and then we'll copy that into our variable we're going to use. We're going to set a flag here. We're going to update the argument index. The argument index is like an array. It starts at 0. We started at 1 because 0 was our ./sim. And then we end our argument loop. Now notice that I did this way back when I first wrote the loop. So I still have structure right here. I understand where my loop starts and ends. Now up to this point, we've been simply looking at the different input components and checking to see what we do and do not have. If at any point we set the program run flag to false, we had a failure of any kind, then we're going to come down here and show the error message here. We'll do that with a printf, and then we'll provide the command line information to the user. And once again, we'll do that show program format that we used up above. Now we will check for the program run and config upload flag. That will tell us that in fact we need to do something with config, and we're almost always going to have to do something with config before we do the other things. Once we're going to do that, we're going to upload the config file, and that's going to be get string length, which we have from our string utils, but this is going to start by getting config data. Now I have already put together some stubs and some specs here. So I have a get config data, opens a file, acquires configuration data, returns a pointer to the data structure, and it returns a Boolean if it fails or succeeds. Now normally I'd leave this empty as a stub function. However, I want to see it work when I actually run this program, because we're going to run the driver and we're going to verify that it actually works correctly long before we get some of these other things working. So we'll come back here. we're going to check for that config display flag. We've uploaded it now. Do we need to do it? If we're going to, then we will do a display config data. Once again, we'll come down here and we'll do display config data. And once again, I'm going to display the operation here so that I can tell that the function is called, even though there's nothing in it. I can verify before I get done, when I do my step 4, that this will be a complete program I don't have to go back and look at. If the file did not upload correctly, then we'd have a file upload failure. Then we're going to show an error message with a printf. We will unset that program run flag, and then we'll move on. Now, if the program run flag, if it got unset here, then obviously that's going to stop anything that happens below it. But as we continue on, we check for that. We're going to upload the data file. And again, this is when we're going to check for success. Let's take a look at it. We'll come down here and we'll do get metadata, which returns the Boolean to tell it we were succeeded or false. And by the way, normally I'd set this to false, but I'm setting it to true again to make sure I can test my driver function correctly with things coming back from this. Again, we acquires the metadata items, stores them in a linked list, provided its file name to it, and also returns the success Boolean-wise. It returns a linked list head via the parameter and returns an end state error message. If this comes back as false, this will also come back with a string in it saying, here's what went wrong. And again, we've got a string here just saying it's running. We've got a true right here to make sure that the driver function keeps working. If that does work, then we're going to check the metadata display flag. If that's okay, then we will come down here and we will display the metadata. Let's come down here. The display metadata is pretty straightforward, iterates through the list. This displays them in a somewhat formatted form that you have already seen in the example that was provided. Again, here we'll simply display that it worked, it was called, and that will keep our driver function working. So once we have the display metadata done, then an alternative, it could be an either or both here, but we'll check to see if the run simulator flag was set. If we do, then we'll go ahead and run the sim. And running the sim itself is again pretty straightforward. We have a printf that shows us that it would be running here. This is really a very large function. It'll be doing a lot of things. It will be the actual simulation. And so we'll be working on that later. You will be working on that later. And so, but it's the master driver for the simulator, does a simulation. It also does a file output because this requires a log file, as you will read about later. Coming back to our step 3 here, we'll do an otherwise, which is an else. We'll do a printf for the error message. And one thing that's going to happen in both our get config data and then also later our get metadata here operations is that is going to complete 2 complete sets of allocated data. And so we get down here, we're going to need to clean up the config data here. And again, we'll see that down here, clear config data. And again, I have to be called here. It cleans it all up and puts the memory back to the operating system, the real operating system. Same for the cleanup metadata. We'll have a clear metadata list. And again, all it does is iterates through the opcode linked list and puts back all the memory in a process called free. We'll show the program end, which will be just a printf, and then we'll return success. So this is our step 3 for our main program. Everything else here is support. The run sim, the get metadata, the get config, all those other things, those are support. But this is the program, and this is why we're at step 3, putting in all the functions we're going to use here. So having put together the step 3 now, we really have a line-by-line definition of what the program is going to look like. Not only do we have everything the program is going to do, we know how we're going to sub out all the little components that are going to come back to this. Now understand, those components are also going to sub out some things, so there'll be subroutines there, functions that will be called by those. But for right now, what we really want to do is go to step 4, where we will actually write the code and run the program, even though it won't be complete. So we will finish this one up here.